Okay, I'm trying to. Okay. Good evening. That's it. So the stream is behind by a few seconds, but I think we'll use it that way. But good evening, everyone, and it's nice to be here. My name is Temi. I'm a software engineer, and this is hacking the data layer for AI with Filecoin. So, about myself, I am Temiloluwa Adelowo, and I am a software engineer and a Filecoin Orbit ambassador, and I'm also a serial hackathon uh, participant. So, I mean, a bit of me, how I got into the Filecoin ecosystem was actually through hackathons as well, sometime in 2023 or so. And I built at the hackathon, I won prizes, and I got invited to one of Filecoin's programs, which at that time was the mainnet cohort when they were launching the FVM, which is Filecoin's Ethereum compatible blockchain. So we're just going into our goals for this talk. Yeah. So first, we have to understand what decentralized storage means and how Filecoin and IPFS work. And then next, we'll go through exploring a machine learning pipeline built on Filecoin. And then after that, you can see what else we can build using Filecoin. So I don't know if any of us has heard about Filecoin or used Filecoin before. But then the next slide is why decentralized storage for AI. So why we need IPFS and Filecoin or as a whole decentralized storage for AI networks is basically first of all for resilience and fault tolerance, and then for content addressing versus location addressing, data sovereignty and ownership, censorship resistance, and to create a decentralized storage market. So, in today's use, where we have centralized systems, your data can be easily taken down by these centralized data providers. So examples of centralized data providers we have today, we have AWS, we have a few others, Google Drive and the rest. But then your data can be easily taken down, and your um, privacy can also be infringed. So for what Filecoin tries to enable is a fully decentralized storage system where your data, first of all, cannot be accessed. It is censorship resistant, and then you can always have access to this data whenever you need to. And that is why Filecoin exists on IPFS. So we're just going to compare and contrast IPFS and Filecoin because they are two individual terms, two individual things on their own, but then working towards the same goal. So first off, purpose. IPFS purpose is decentralized file sharing and retrieval. Meanwhile, Filecoin itself enables reliable and permanent decentralized storage with incentives. So with Filecoin as a data or storage provider, you can earn incentives on every piece of data you help store. And then, I mean, of course, nobody will store your data forever. So incentives are a good way to make these people keep your data or store your data on your behalf. So secondly, we have the storage mechanism. And IPFS uses a network of nodes that store your data. And then on Filecoin, your files are stored on nodes that provide storage for pay. So you pay for um, uploading files on Filecoin. And then for incentives on IPFS, there are no incentives, meaning that your participation as a node is voluntary. So you get no rewards exactly for storing data on IPFS. Meanwhile, on Filecoin, the field tokens, the Filecoin tokens, are used as incentives for data storage and retrieval. So for every piece of data you store on Filecoin, you pay a little amount of field tokens, which serves as an incentive to um, nodes and miners. And then also for retrieval, you pay a little fee in Filecoin tokens. So lastly, data persistence. The image box there is blocking the persistence there, but data persistence is not guaranteed without pinning services. And on Filecoin, it is designed for long-term and reliable data persistence. So what this means is in IPFS, we have something called data pinning. So this is where um, basically, if since data cannot be completely deleted on IPFS because it's permanent storage, your files can only be unpinned by the storage provider. And basically, that means your data acts as deleted. And since nodes are not paid for storing your data, of course, they cannot store your data forever for free. At some point, they will need their storage or their space, and then we have to unpin your data. And then Filecoin is designed for long-term and reliable data persistence. So because you paid or you gave the nodes incentives to store this data, you can stay for as long as you need it. But then some storage services make it possible, or they act as like data pinning services on IPFS. And examples of those services, we have Pinata, we have Lighthouse, we have Pinata and Lighthouse, and I think Sriracha also does the same thing. And then recently we have some more infrastructure that work as data pinning services and providing hot storage to users on Filecoin. So examples are all the ones we have here. So Sriracha is the one with the red, is it chicken? Yes. And then Lighthouse is store. The blue one is Akave, and then Pinata and Infura. So this, okay, let's wait for it to do the bit. But this is the storage evolution of the IPFS and Filecoin ecosystem. So the underlying layer, or what the layer that started it all, is IPFS and acts as the data pinning layer. And then built on top of that, we have Filecoin, which is the storage layer and acts as the layer zero. And on top of that, we have Filecoin VM, which is the FVM, the virtual machine, and that enables programmatic storage. So that's where you have smart contracts, or in the Filecoin ecosystem, we call them actors. And they can also be written with Solidity and deployed on the Filecoin virtual machine. And built on that, we have IPC, and IPC enables performance dApps with chain scalability. Okay, so we have Filecoin services. So Filecoin services is a new service introduced by Filecoin and basically enables users to store the data directly on chain. So you can utilize decentralized storage on chain directly for your hot storage. And currently is made available using the Synapse SDK, which is a TypeScript and JavaScript SDK for builders, and is what we're going to be looking at today, what we're going to be using for our test project here. So for our test project, let's wait for that to upload. All right. So for our test project, we're going to be building a deep learning workflow using Filecoin via the Filecoin services or the Synapse SDK. So things we're going to do here is we're going to source and upload a data set to Filecoin, or in our case, we're going to generate and upload a data set to Filecoin. And then we're going to train um, a model on the data we have on Filecoin. And then we're also going to upload our trained model to Filecoin. So we're going to be doing all this here. And I'll just go ahead to, okay. So I've worked on a demo repository that we could use for this workshop. Okay, sorry. I'll try to zoom in. Yeah, I'll try to zoom in so it's more visible. Yeah, yes. This is not enough on the screen. Okay, let me zoom in again. Okay, I think that's visible enough. All right. So um, basically, I'll show you the file upload service using the Synapse SDK. I'll show you file download service using the Synapse SDK. And the Synapse SDK works in a way that you can directly interact with the Filecoin virtual machine to upload your data. So um, part of the things we'll be using, or part of the requirements are firstly um, a private key or your wallet, the private key to your wallet. You put that in your .env file so it doesn't get public. Would also need test field tokens or TFIL tokens, which can be gotten from the ChainSafe faucet. And we also use USDFC tokens, which is the stable coin on the Filecoin ecosystem. So I already have test tokens. I have TFIO tokens. I have USDFC tokens as well. So I'll just be going straight to showing you how the entire thing works. So, okay. Okay, so this is the file upload component. We have to wait for that one to capture. Yeah, so this is the file upload component. And if we look through, we can see from the dependencies that we have Synapse imported from fileos/synapse SDK. That's the method we're using. And we also need guitars and a couple of other dependencies to make this functional. And for the uploaded info or the file we're uploading, we need the file name, the file size, the comp, and the TX hash. The comp is basically the ID of the file that we're uploading. And then the transaction hash is the transaction in which the file upload was completed. And then we have a hook to upload the file to the Filecoin network using Synapse. So we have a few methods defined in that function. All right. So first of all, we have a signer. We use Ethers for signing our transactions. We're currently on the calibration testnet network, which is Filecoin's testnet network. And then for how we enable this, first of all, we convert the file to an array buffer, and then we convert that buffer to UI in array. So that's an array of like integers. And then we also create the Synapse instance. So that's using the synapse.create method, which is defined by, or which is exported from the Synapse SDK that we imported earlier. And we have the signer, and then with CDN is a method that helps us to enable or use CDN optimization. So it makes our file uploads and file downloads faster because it tries to utilize CDNs available. And then we get the proof set for the data we are uploading, and then check if we have a proof set, and then we include the proof set creation fee. So all fees to be used in this transaction are going to be covered with USDFC. And then next we check if we have enough USDFC to cover the transaction cost and deposit if we do not have enough. And then we also set up the storage service and the proof set. So the proof set we created before, we include it here and then set everything up. Then the last thing we do in the upload flow is to create the storage service. So after creating the storage service, then we upload the file to the storage provider using that same storage service we have created before. So to make it easier for you to follow up, I'll share the repository link. Just 1 minute. All right. So you can follow through um, the link. And Okay, I'll send it to Telegram group. Yes. Okay, let me send it to you. All right. So we'll have the um, link sent in now. And then you can follow on from there. Okay. So we've seen creating the storage service, and then last thing we do is to create and upload our file using the storage service we've created previously. And then once that is complete, we get the transaction hash, and then the transaction will be confirmed after which we receive our um, ID file ID for the uploaded data. Okay, and then we see our file successfully uploaded on Filecoin. So to test this, I'll run the server and then just show a demo. Okay, so it's currently running, but to run it, you can use pnpm dev. This is going to be after installing the dependencies needed using pnpm install in the fs upload app folder. Yes. Okay, so that's running currently, and I'll just access it from here. So I've also worked on a service that helps us to generate data sets. So just a demo data set that we'll be using for this workshop. So we have the dataset generator file, and we're going to be generating health data. Okay, so we just generate a sample data set, and to go to the generate data set tab. The number of records is currently set to 100, so we'll just generate a data set. And once that is generated successfully, I'll try to upload this data set in the next code. So, oh, okay, this is behind, still behind. We don't need to code. All right. And then I'll upload the data set I've created, then submit for upload. What happened? So to upload the file to Filecoin, we need to approve the transaction, and then it will take a bit of time to upload, and then the transaction hash would be verified. So once the entire flow is complete, we should see a model just below that shows the information about the uploaded data we have just sent to Filecoin. Is it on this group? On Telegram? Yes. I can send it there. Okay. Sent it. All right, so I've sent the repo link to the Telegram while we're waiting for the transaction to be complete. Usually takes a bit of time. Yes. Oh, I'm still sharing. Oh, Okay, so we should be able to view all our uploaded proof sets, and this is the proof set of Oma. I'm trying to screen back again. Okay, so on the view proof sets tab, we should be able to see our uploaded proof set, and the last one here is the one we just uploaded. So I'll also go to the download file tab, so we'll be able to retrieve the file we have uploaded. Okay, and then I'll save to device. So basically, this is showing we uploading data, we're retrieving this data, and we can use the same data we have uploaded to train our data sets. So I have also worked on a demo project for um, our data set. So it's just a very simple model training project. And we're just going to run the command using the um, data we have. Right. So because it's a Python project, um, first off on downloads, you have to set up the project by installing all the dependencies using pip, which is the default Python um, installer, similar to npm for JavaScript project. So since I have that installed, I'm just going to run the command that trains our data, and then I'll output the trained data. So first off, I'll go to the folder, and then I'll just run the command. And then I'll just put in our data set. Okay, so I've been able to run the command, and then we have had our data set trained on the data we have. So alternatively, we could use the CID of our uploaded files, if you upload using other um, storage providers, the Lighthouse, the Storager, and the rest of them. And then it will automatically retrieve this data from those providers and train on it. So we also have the training outputs, which are a few files generated for. So we have the total number of patients, and all the parameters we've trained on and the outputs. And then we also have like detailed predictions for each of them, and then training results as well. So this outputs can also be uploaded to Filecoin using the same method we used earlier. And then basically that shows we uploading to Filecoin. So we've been able to upload our custom data set. We've also been able to train our data, right? We've been able to upload our trained model to Filecoin, and then we can also query the model when we need to. So basically that shows the entire flow of using Filecoin as a data layer for AI. So just to recap, so we've seen that we could upload a custom data set to Filecoin using our storage provider of choice. We could fetch the data set and train a deep neural network on it. We could save and upload the trained model to Filecoin. And then we could also query our trained model by loading it to a project and making predictions. And we can also extend this functionality to any AI model available. Okay. So next step, building on Filecoin. So this is also a QR code to the repository we just used as a sample. So you can also access it if you're not able to get the link from the Telegram group earlier. And here's also the Field Builders Telegram channel. So here you can ask questions and get your answers and connect with other builders in the Filecoin ecosystem. And to get involved with Filecoin, basically, we have the Orbit program, which is a community ambassadorship program that Filecoin runs, where every user can be an ambassador. We have different orbits. We have the content orbit, we have the builder orbit. So builders can be involved in the Filecoin orbit community, and as a content creator, you can also be involved in the Filecoin orbit community. So this is the registration link if you want to join the Filecoin orbit program. So you can just scan, and then it's a form. You can fill the form as well. All right. Thank you, guys. So I don't know if any of us has any questions, so we could just walk over it together. Do you have any questions? Okay. Okay, Filecoin entirely. Basically, every Web3 product can be built on Filecoin. So, um, Filecoin has the FVM, which is a blockchain on its own, an Ethereum compatible blockchain, and this means you can build any project that involves or needs smart contracts to run can be built on Filecoin. Any product that needs data, so if you need to upload data sets, if you need to access data, or even upload user data, which it consents to, you can upload to Filecoin and use it as your own storage layer. Yes. So basically, every type of product can be built on Filecoin. Financial products, DeFi, can be built on Filecoin. So it's just, yeah. So any other questions? Thank you.